Students, in our previous classes we have read about the reaction of metal with acid and bases. So today we will discuss about how do metal carbonates and metal hydrogen carbonates react with acids. So dear students, you have given the activity in your book 2.5 activity. So to do this activity you have to need two test tube. Okay, and you have to take salt, that is metal carbonate and metal hydrogen carbonate. Metal carbonate is taken here sodium carbonate, and metal hydrogen carbonate taken as sodium bicarbonate. And you have to need acids, so acid is taken as hydrochloric acid. So to do this activity we have to prepare a freshly prepared lime water in a test tube, another test tube. So look, this is the apparatus fitted here. In this apparatus a test tube is taken, label as A. In this test tube we are put some sodium carbonate, 0.5 gram of sodium carbonate, that means Na2CO3, and after that we are fitted with a cork and a delivery tube is there, and a distil funnel is there. So this distil funnel is actually a small funnel, okay, through which we can allow to passes hydrochloric acid. So when we pass the hydrochloric acid, then there will be reaction between the hydrochloric acid and sodium carbonate. So between the metal carbonate and acids react, they will evolve some gases, and that gases, when we allow to passes through the delivery tube and passes to the freshly prepared lime water, then it is found that this lime water turn milky, and there is a milky, and there will be a fresh white precipitate occur. So actually what is happening, or what type of reaction is occurring here, we will show. It is written in your textbooks here. So when in the test tube A, that means reaction of dilute hydrochloric acid with sodium carbonate, then it will be occur sodium carbonate, this is Na2CO3, it is solid, react with hydrochloric acid, aqueous mean in dissolving with water, liquid form. So when they react, it will produce salt, 2NaCl, common salt, aqueous, plus water plus carbon dioxide gas. Okay, so that means metal carbonate react with acids, then it will produce salt, metallic salt, plus water plus carbon dioxide gas. So carbon dioxide gas is evolving. Okay, similarly when we take, in place of metal carbonate, we can take metal hydrogen carbonate. So actually we have taken two test tube. So in test tube B, if it is B, then we will take here sodium bicarbonate or sodium hydrogen carbonate, and when we added dilute hydrochloric acid, then also reaction occur between the acids and hydrogen carbonate, metal hydrogen carbonate, and it will evolve gases. So that gases is when passes to the lime water, then that lime water again turn milky. Okay, so and a white precipitation occur. So the reaction is like that. In test tube B, sodium bicarbonate or sodium hydrogen carbonate react with acids, then it will form salt plus water, and carbon dioxide gas will produce. So how do we prove this this gas evolve is a carbon dioxide? This indicates that when it is passes through this freshly prepared lime water, this lime water turn milky and also a white precipitate occur. Okay, so this indicates that when carbon dioxide gas passes to the lime water, then the lime water will become milky as well as if it will form a white precipitate. So that white precipitate is actually calcium carbonate. So I will show you here the reactions. So on passing the carbon dioxide gases evolve through the lime water, then reaction will occur like that. Calcium hydroxide, it is your lime water, plus carbon dioxide gas, then it will form calcium carbonate, white precipitate plus water. Again, when we pass excess carbon dioxide gas in the lime water, okay, then it will take like that reactions. So here on passing excess carbon dioxide, the following reaction take place. Calcium carbon is there, water is there, as well as carbon dioxide gas passing, then it will form calcium bicarbonate soluble in water form. So this calcium bicarbonate is actually cleansing lime called. Okay, so it is written lime, chalk and marble are different form of calcium carbonate. So they are calcium carbonate, marble is also calcium carbonate, limestone also calcium carbonate, chalk also calcium carbonate, but they are of different calcium carbonate. Their composition is little different. So all metal carbonate and metal hydrogen carbonates react with acids to give corresponding salt. A metallic salt will form, carbon dioxide gas will produce, and water will be formed. Okay, so from these reactions we can conclude that metal carbonate or metal hydrogen carbonate, that means react with acids, then it will produce salt, carbon dioxide gas produce, and water will be produced. Okay, now next, how do acids and bases react with each other? So to do the reactions, we have to do the activity 2.6 given. So in this activity you have to take 2 ml of dilute sodium hydroxide solution. So dilute sodium hydroxide solution is a base in a test tube or in a conical flask you can take, and you have to need phenolphthalein indicators, and also you have to need acids, HCl, hydrochloric acids. Okay, suppose I have taken here a test tube or a conical flask. In this test tubes I have taken base sodium hydroxide, NaOH. So when we add drops, a few 1 drops or 2 drops of phenolphthalein indicator, then it is found that this actually sodium hydroxide is colorless. When we apply 2 drops of phenolphthalein, then this sodium hydroxide will change to pink in color. Okay, again when we add drop by drop hydrochloric acid, then it is found that the pink color of sodium hydroxide or this solution will become slowly disappeared. Okay, so this indicates that the base will be nullified by the acids. Okay, by adding sodium hydrochloric acids, when the pink color of this solution disappear, again when we add sodium hydroxide again drop by drop, then it is found that the pink color again reappear. Okay, so from this solution it's give us conclusion that acid and when base react with each other, they will nullify. Okay, they will nullify the effect. So it is written here in your textbook, in the above activity we have observed that the effect of a base is nullified by an acid and vice versa. So the reaction taking place is written as sodium hydroxide plus acid when added HCl. That means sodium hydroxide is base, HCl is acid, react, then it will form salt. NaCl is salt. It is a nullified or neutral salt plus water will be formed. Okay. So the reaction between an acid and base to give a salt and water is known as neutralization reaction. Okay. In general, a neutralization reaction can be written as base plus acid, or you can write acid plus base gives salt plus water. Okay. So this salt form is neutral salt. So next, reaction of metallic oxides with acids. So to do or to understand this, we have to know the activity 2.7. So in this activity 2.7, you are asked to take a small amount of copper oxide. Copper oxide is brown in color, okay, in a beaker, and add a dilute hydrochloric acid slowly while stirring. So you have taken a beaker here like that, and copper powder is taken here. After that, you are adding hydrochloric acid slowly and you are stirring. Okay. After adding hydrochloric acid, the color of copper oxide, which is brown in color, changes to blue green. Okay, blue green in color. So what is happening here is written here. You will notice that the color of the solution become blue green and the copper oxide is dissolved. So copper oxide is solid in powder form. Okay, when we added hydrochloric acid, the hydrochloric acid on adding, the color of brown color copper oxide will changes to blue green, and copper oxide will completely make solution in here, dissolve here. Okay, so the blue green color of the solution is due to the formation of copper chloride or copper to chloride in the reaction. So the general reaction between a metal oxide and acid can be written as metal oxide react with acid, then form salt plus water. So if we write the chemical formula of this above reaction, then it may be we are taking metal oxide calcium oxide plus acid is what? Hydrochloric acid. So when they react, then it will form copper to chloride plus water. So when we balance, then there will be 2. Okay, it is solid as it is aqueous. Clear? It is aqueous form. It is liquid. So they will form the copper to chloride or copper chloride, which is green in color. Okay, blue green in color. So actually metal oxides is in their nature, they are in basic in nature. Okay, but sometimes some metallic oxides may be basic in nature. Okay, so generally metal oxide does not react with base. If the metal oxide is in basic nature as well as in acid nature, then they will be react with both acid and base and form salt and water. So that type of oxides are known as amphoteric oxides. Example are there zinc oxide, aluminum trioxides. Okay. Next we will read reaction of a non-metallic oxide with base. So actually non-metallic oxide react with base and metallic oxide react with acid. So to know this reaction between non-metallic oxide with base, it is asked to look the activity 2.5. So actually in activity 2.5 we have taken what carbon dioxide is passing through quicklime, calcium hydroxide. isn't it? So when it passes, then it will form calcium carbonate, COCH3, isn't it, plus water. So it is written here, calcium hydroxide. When carbon dioxide gases passes, then it will form calcium carbonate, white precipitate, and water. Okay, so this carbon dioxide, it is a non-metallic oxide, okay, and calcium hydroxide is a base. So non-metallic oxide react with bases, then it will form calcium carbonate with water. It is a salt and water. Okay, so from here we can conclude that non-metallic oxide also react with base and form salt and water. And these non-metallic oxides are generally acidic in nature. Okay, acidic in nature. But metallic oxides are basic in nature. So students, in the next video we will learn this: what do all acids and bases have in common? Okay.